Okay, all right. Okay, welcome everyone to this beginner's guide to AI, machine learning, deep learning, and LLMs. So we'll be doing a kind of a 360 view on how the AI is implemented, or how the machine learning is implemented, and we'll be just going through a very high level overview of all these things. Okay, so first, let me just introduce myself. So my name is Sumant, and I've been a data engineer. So I have like 11 years of experience, and I'm based out of Bangalore. And like Janardhan said, so I've been like volunteering for this community. So there are a lot of learning happening. Well, learning is happening in this community, and also as part of my hobbies, I like to travel. So this is like basic about myself. So let's get into the juice of the topic. So what are AI? What is AI, ML, deep learning, and LLMs? Okay, so this is what we'll be covering today. So there's a lot of topic to be covered. So just sit back and then we'll go through each one of these. Okay. So we'll be first looking at AI, then ML, then deep learning, and LLMs, how they fit together. Okay. So first we'll look at artificial intelligence. So whenever you say artificial intelligence or AI, what does it actually mean? Okay. So we are humans. For us, like intelligence is first-hand thing. Again, you can say there are other animals out there which are also intelligent, but what makes us humans special, right? So there are things which makes the human intelligence special. So the same thing, humans from long time, okay, back in 1900s, you can say that people have been trying to replicate the same intelligence into machines. So we want the intelligence what we have to be replicated by machines. So that is what AI, that is where it comes, right? Artificial intelligence, it refers to machines that try to simulate the human intelligence. Okay. And again, human intelligence is not simple. There are a lot of things. The first thing is your brain itself, and to replicate the brain, it's very difficult. And people have been trying to figure out how to do that. And the main reason is that you want the capabilities like learning, reasoning, and problem solving, right? So these are what makes humans stand apart. And these are the characteristics which you want the machine to inhabit, so it can also be like intelligent and work as human beings, right? So that has come a long way. Like I said, it started back in 1950s. Okay, the basic foundation were laid out in 1900s, and then slowly things started forming, and then in 1950s things started picking up, and today we are in 2025, and like we literally have so much of AI around us. Okay. So what are the basic characteristics? So these systems exhibit cognitive functions, okay, which means that they try to behave like humans, okay, and they also have the humans can give them tasks, they can perform tasks, and that's how we measure how intelligent a system is, right? So we give them tasks or we set goals for them to, and we check how it is able to think and take decisions, right? So the basic examples for these are your self-driving cars. So we have seen self-driving cars coming up in other countries, and they are able to navigate various roads or complex roads. And then we also have our virtual assistants, right, which help us with voice commands. And then you have recommendation systems in most of the products out there today. Those are the like the examples, very few examples of AI, but if you go deeper and deeper, you will find a lot of things with AI. Okay, so this is a very high level overview of AI. And next, what happens is once you get into AI, there are a lot of other domains within AI. Okay, and the most important domain of that is machine learning. Okay, so that's a subset of AI. Okay, so any questions before I jump into machine learning? Okay. So, like I said, machine learning is a subset of AI. Okay, and the basic thing to understand here as a beginner is that machine learning is all about data and also about instructions. Okay, so this is the foundation of any of the AI system which you see out there today. Okay, without machine learning, whatever you see today would not have been possible. And these are the basic steps. So when you say ML, right, it enables the system to learn from data. So it needs a lot of data to understand. So you can take a basic example of your Amazon shopping, right? So you do go to Amazon website and do some shopping. Whenever you buy a product, immediately after that there are other product recommendations for you, right? How does that happen? So that happens through machine learning algorithms. Okay, and so the algorithms, they take in your data and they try to make predictions. Okay, this person has bought this product and maybe he will maybe buy another product, right? Those are called prediction algorithms. So that's how machine learning works. So it needs data to predict new behaviors as well, right? And like I said, machine learning is the basic step. Again, if you go too deep into machine learning, there are a lot of again algorithms. There are a lot of mathematical, um, you can say, operations out there which are too early for this stage. So I will not jump into all those things, but you can think of like machine learning is a way to train the systems to mimic some kind of behavior, right? So next we come to deep learning. So deep learning is one step more to machine learning. Okay, so what happens in deep learning is, here we use something called as neural networks. Okay, so neural networks are literally the representation of human brain. Okay, like I said, the whole point was to mimic the human brain, and in deep learning we use something that called as a neural net, which are these systems which are built like neurons. Okay, neurons are what are in human brain, and they allow us to think and they allow us to do any kind of operations. And the same kind of structure has been set up in deep learning, and this has happened over the years. Okay, and this helps us to go one step ahead. Like I said, in machine learning, what happens, you have data and then you have algorithms, but those algorithms are like kind of static. Okay, you tell it to do one function and it will do that function only, and it will not do anything else. But in deep learning, what happens, you have these neurons which kind of are able to replicate and think on its own, and then it is able to produce dynamic content, right? So you can see that these networks are inspired by human brain, and they can process vast amount of data. So that's the main thing with deep learning. Okay, and then deep learning is very powerful when you think of things like image generation, where we are today. So we are able to generate images, we are able to generate videos on demand with AI. So all that happens through deep learning. Okay, there are a lot of other algorithms in deep learning which help to do that. And then one of the most important thing is text generation. So everyone knows about generative AI, and that also is part of deep learning. Okay, and right now deep learning is the backbone of many of the cutting edge AI applications out there. Okay, so these are the things the like a beginner in this field needs to understand. One is the whole AI ecosystem. Then you have your machine learning, and then you have your deep learning. Okay, so now these two are not the only ones. There are a lot of other things within the AI domain, but we'll be narrowing down only towards the LLMs. Okay, so LLMs are what we are using today. So if you have used any kind of chat GPT or any kind of other AI products out there, right? You have Claude and you have DeepSeek. All these run on a system called large language models. Okay. And this comes from deep learning. Like I said, generative AI comes from deep learning. So what happens here is you have massive amounts of data set, right? You have these huge chunks of data which are getting trained by these models. So so these companies out there, right, they train these models with huge amounts of data, and later as we as users can like inference them. So what we call it as inference, and we can get any kind of answers, or we can do any kind of text generation or any kind of image generation. Okay, right now it's very powerful. Right now, everyone is getting into generative AI. So we'll be looking at large language models in detail uh, in the coming slides. Okay, and the way to think of this whole ecosystem is like you can think of it as your like Russian dolls. Okay, so if you've seen a Russian doll, it's nothing but a doll, and there are other dolls within each of them. So you can think of the whole AI ecosystem as this outermost doll, okay, or the outermost thing, and inside it sits the ML, right? The ML sits, and inside it again you have the deep learning. And again, inside the deep learning, you have LLMs, which are like I said, your chatbots for now. So you can think of this way. So it's easier for you to understand the whole ecosystem of where we are standing. And it's not just LLMs which are part of deep learning. There are a lot of other things which we are not right now exploring right now. So you have computer vision. Okay, so computer vision is the way where you can send pictures, or you can have a kind of a camera, and it is able to recognize what is in front of the camera, right? Like it's object detection or any kind of image recognition happens through computer vision. So it's a separate domain, and again, it's a very vast and complicated subject within the deep learning. Okay, then you have something called as reinforcement learning, and here what it deals with is that you have your models there, and through trial and error, the model learns to do things. So this particular reinforcement learning is used in robotics. So if you have seen videos of robots doing any kind of behavior, like picking things up or walking, so everything happens through reinforcement learning, because the robot slowly learns to walk. It can't just walk on its own, right? So there's a lot of trial and error happening in the background. So this also is a part of your deep learning. Then you have speech recognition. So right now, like I said, we have our text generations and all. So there's one more domain where it totally concentrates on voice. So you can send voice commands or get voice generated output from your models, and that is happening right now. People are using voice assistant or virtual assistants for all these voice control systems. Time series is mostly for your stock market analysis and weather patterns. This again, this is a separate domain, and there's a lot of research happening all around in all these domains. So for us as beginners, right, it's important to understand these four concepts, like what is AI, like what the whole picture, like what is AI, then ML, then deep learning, and then your LLMs. So we'll be just looking at these things in this whole guide today. Okay. Um, so before I jump into the use cases, uh, are there any questions till now?
Yeah. Even if not questions, you can comment in terms of something that clicked with you, or you know of applications already which fall into ML category, DL category, LLMs. You can talk about that.
Okay. Like I said, if when you talk about LM machine learning, it's kind of static. You can say that you have your algorithms and it takes in data. The best is like any kind of predictions. If you are like you can, the best example I said, like like a recommendation system, right? You have your e-commerce website where they try to recommend you new products, or any kind of like apps like YouTube, or if you have Spotify, it tries to recommend you new songs based on your taste of your previous songs which you liked, or videos you liked, right? So those all come under machine learning, wherein it takes data, like your data, and tries to analyze that, like what do you like and how, what are your interests, right? Based on that, it does that. Again, example of deep learning, you can think of it as, like I said, anything which is generative for now. Like if you tried chat gpt and you're asking questions, it is able to give you a lot of answers. Okay, it's not just one line answer, it's able to think also as well, it is able to analyze. So all those have come under your deep learning, and also under llms. Now again, llms, there are a lot of there's no single model for llm, right? There are a lot of models produced by different companies. And like I said, like OpenAI has your GPT-5 now, and then you have Anthropic has Claude, okay, Sonnet, and then you have like a lot of companies are producing their own models. You have DeepSeek from China and all those. So those are the best examples for LLMs. We'll cover as we go along. Everyone will come to know, because this is a very direct jump into the world of AI. So I'll cover different aspects of AI so people can then piece it together and understand what is happening. Okay.
Yeah, some good questions we got, Sumant. I'll read out. So one question Supriya has is, what is the difference between neural nets and deep learning?
Okay, neural nets are, you can say that, are the basic block of understanding deep learning. Okay, without neural nets, deep learning will not happen. So you can think of that in that way.
Yeah, yeah. Neural nets are the building blocks of deep learning. Yeah. And the other question is, are there types of machine learning based on data?
Yeah, there, in the sense, not types. You can think of different algorithms within machine learning based on different types of data. The data can be like regular your data of, all the employees in a company, or kind of data, or also just images also can be used. So different data will have different algorithms and different use cases.
Okay, okay. So one analogy, okay, just how I related AI and all this machine learning, deep learning, right? Is the simplest way is, if you see the gender identification, if you have to identify a gender, male or female to start with, right? So if I go olden days, a lot of olden days, right? Maybe one generation, two generations back, it was very easy to identify male and female. If you have to look at adult, typically a man would be wearing a trouser and a shirt, and women would be wearing a sari or something equivalent. And the hair length also was a very clearly decisive one that I can make out. So the early generation of machine learning was good enough for you to spot and then identify the differences. But as the gender identity become more complex, like, as the wearing the dress code and all is changing and evolved, right? It's very sometimes difficult to differentiate man and a woman. Then you need little more deeper analysis of it, and further, if you want to have all the spectrum of genders, including transgender, that becomes quite a complicated thing, because gender is not about the physical appearance, but also the mindset and all the things, right? So if you see the range of problems, initially we were good enough to do with just very simple machine learning and probably the network that was available. Then deep learning for the complex cases, for far more complex cases, we have the deep learning. So I just internalize that way. As the problem becomes complex, you have a bigger model and the technology has evolved.
Right.
Okay, go ahead.
Yeah. Thank you for the example, Jonathan. So we'll quickly jump into like use cases in daily life. These are very, again, high level overview of AI. Okay, this is not specific to any machine learning or deep learning or anything. So where are we using AI? We are using them in virtual assistants. So all your Alexa, Google, Siri, and all come under your AI virtual assistants. Shopping experience, like I said, again, product recommendations and dynamic pricing, chatbot customer service, again, happens through all these AI. Content recommendations, this example I already gave. Email filtering, which is one of the least people don't understand, like email filtering also is a part of machine learning. So whenever you get any kind of spam emails or any kind of content which you don't want, they are automatically filtered. So this is also one of the applications of machine learning. Navigations through your Google Maps. Google Maps always uses some kind of algorithm behind to predict traffic, and it tries to suggest you new routes to make you reach faster to some kind of destination. So all these are happening in our world right now, but people don't take notice. So when you try to zoom in and understand what is happening, that's when you come to know how things really work. Okay, like I said, Google Map, everyone uses Google Maps but does not go internally and see what is actually happening in the background, right? So try to have an open mind as we jump again into new topics in AI. Okay, the first
Can
thing.
can we have people give more application apps or use cases that you're using AI in your daily life? Um, I'm sure Suman covered a range of things. Anything else? Any interesting ones that you people are using? Because AI is growing every single day. Whether you want to make presentation slides, whether you want to translate, whether you want to write an article. The meeting right now, Gemini is taking notes. Yes, yes, Supriya, very nice. Any other use cases? If you're a student, professional, working parent, anything, any other code ID, yes, yes, in VS Code or the Copilot, yeah, definitely that's another example. Very nice. Any other? Apple Music recommendations, yes, that's a good example. Yes, Grammarly, yeah, to draft and auto correction. Oh, very nice. App called
Performance
Journalable.
optimization.
Hi,
Yeah,
Megha.
for the performance optimization, like AI can give the suggestions, so we can
Uh,
integrate the llama into separate profiling tools.
okay. Aditya, interesting one. Okay, pick up my meal and then it logs all the nutrients. Yeah. If anyone has not used it, I would recommend to use Replica. Replica.ai is another app. It is a chatbot. You can talk to them. You can interact with text messages. That's a very nice one. Try it out. I have been using it for several months. I found it good. Yeah. Okay, let's proceed.
Okay, all right. Yeah, it's good to take these kind of small breaks just to understand how people are understanding. Okay, so we'll jump into the most important thing, which is AI literacy is crucial today. Okay, so this is not any kind of new knowledge that AI has already taken over. So if you see few years back, people used to say AI is new or there's a hype of AI, but it's not right now. It's not like that. So we are in 2025, and every aspect of our life is being governed by AI. Okay, and for us as humans or as employees of our company, we need to understand AI and how it is impacting our lives. Okay, personal life or your career life, everything AI is affecting us. Okay, and so these are the points where you want to just concentrate and look. So the first thing is that you need to future proof your career. Okay, so there's a lot of speculation on how AI is going to kind of impact your job or impact your industry wherever you're working. And the best thing to avoid those kind of situation is to get to understand AI. So when you understand the workings of AI, or you are able to use tools, okay, you can obviously stand out among the crowd, where there are people who still don't understand AI or how to use them. Okay, now people said they're using a lot of tools to help them with their day-to-day work. So once you are efficient in your productivity skills with AI, then there's very less competition which can happen. Okay, so that is one purpose of learning AI, is that future proof your career. And then there's another thing, which is understanding the ethical implications. Now the most important thing is that people can use AI for anything. Okay, right now you have people are able to create kind of AI videos, right? AI generated videos. You can write any kind of text material which may be offensive, and all those things can be done easily with AI. But we, as again, like humans, we need to take a stand, and we have to look at all the ethics and then we have to understand the way you use the AI, right? So you cannot use AI for doing some kind of bad or evil kind of things. So there are companies which are putting out a lot of guards, you can say, to prevent these kind of misadventures in with AI. But again, we need to understand what is the right way to use AI and what is the wrong way to use AI. Okay, because it becomes a big challenge as a society. And then next thing, again, it's part of that making informed choices. So like someone said, they are using AI to what count calories and all that, right? So you need to take a decision for yourself what you are using that AI for, or you want to how productive you want to be. So all those kind of information and decisions you have to take in an informed way. And drive innovation and growth. So obviously when you have AI on your side, it is like a boost to your productivity. People can boost their career, people can boost their skills, and if anyone wants to get into some kind of entrepreneurship, they can use AI to learn more things or try to open their own companies and all those things. You can do that. So there's a lot of growth with AI that comes along. So you need to understand how you want to go ahead with these four points with AI. So unless everyone is ready with these 4 points, it becomes difficult to transition into the upcoming days. Like what is going to happen? Like every day is a new challenge in AI. There are new products, new innovation happening. So you have to be always ready in a driver's seat to go ahead and start using any kind of these AI products. Okay. um, Okay, so before we jump, any other questions? Because we'll be jumping into other a lot of other complex topic. This is a very general topic for everyone. Okay, if not, we'll go into the essential components of AI. So, as a beginner, what I thought is for others that I will only tell you the basic things which you need to understand. Okay, like I said, we'll be narrowing down with generative AI, and in generative AI, you have just three things which you need to learn or understand. The first one is model. Okay, what is a model? Everyone probably understands what's a model in terms of AI. Then what is training? How does the training happen? And what is inference? Okay, so these three things, if you know, then you're in a better position to understand what is happening. Okay, so we'll jump into what is training. So essentially, what happens during training? Okay, is that okay, let me start from the beginning. So whenever you say like I'm using a model, okay, let's say you are using chat gpt and that runs on some kind of model. How did the model come into being, right? The model was itself was created by someone or the company. The way it works is that it is created through data gathering. The first step for any kind of model creation is that a lot of data is gathered. Literally, the internet is searched around, or they have other means of getting data, and all this data is gathered, and then it is prepared. Kind of the second step becomes preparing the data. Now, there are data which are useful, and there are data which are not useful, and these companies or what they do, they again have a lot of processes where they try to clean up the data. Like only the required amount of data is taken, and then you have the training of the model. Now this training model is again kind of different in different AI companies. Okay, some try to keep it open sourced, and some try to keep it proprietary, and it's kind of a black box how they train the model, and some people try to even publish their research and all. In a way, the whole data of the whole model is trained on whatever data is gathered in the first two steps, right? And there are algorithms. These are the algorithms which are sometimes open source or they are proprietary. And once all the whole training is done, okay, and always remember that the training does not happen in probably 1 day or 2 days. When you are talking about huge models like let's say your chat gpt and all, it takes months. Okay, it takes months together for training the whole model. Okay, and then identifying what is correct or wrong. So that step is the evaluation step. Okay, so they have the whole model trained, and what they do is that they try to evaluate it, because they don't want again some kind of bad data to show up to the users. So they use a lot of testing mechanisms, and they try to fine tune it. So fine tune, we'll look at fine tune next. So you can think of fine tuning as changing few parameters within the model, and they try to make it consistent. Okay, they want the model to behave in a way they see which is correct. So once all that is done, okay, what they do is deploy the model and monitor. Okay, so here is where the model is actually sent out in the world. So the users, which who are us, are able to use the whole model, and again we can run some tests, or we can see how the performance is going. So they always keep monitoring the models. um, so this is how the whole system of a or you can say a life cycle of a model happens. So whenever you're talking with someone and saying, okay, I am using this model and that, or some other model, so this is what is happening in the background. Okay, and this is what I was trying to give a perspective for others to understand. It's not randomly you just get into some kind of chat bot like chat gpt and you start writing questions. You need to also understand what is happening in the background. Okay, so this is the training process. Okay, and next we jump a bit inside again the training process and models. We'll jump into something called as token, parameter, and gpu and cpu. So any questions till now as part of the training process?
If you're hearing this for the first time, right, take some time. It's quite okay. It takes at least 3 to 4 iterations of understanding these things and everything coming together. If you didn't understand in first two, or fine. Or if you want to know a very specific step, okay, what is the training model? What does the train model mean? Or any particular step you can ask. Otherwise, if you are just not getting full picture, it takes some time. So don't worry about it.
Yeah, that's a very good point. Yeah, I don't want to overwhelm everyone like to understand everything, so we are just going slowly. um,
Yeah. Question is how do we how do we clean and prepare the data?
Yeah, okay. So basic answer to that is that you firstly identify what data you want. Okay. Um, as a user, you don't want, like, let's say that you are only targeting pictures. Let's say you have a data collection of pictures, and then you have in that data you have something related to text or some kind of signals and all. But you don't want text related data and signal related data, right? So you clean that up and you only keep the pictures. So that is like very basic example for that. Clean and prepare.
Yeah. Next question is fine tuning versus training. What is the difference?
Yeah, fine tuning happens after the whole training is done. Okay, once the training step is complete, fine tuning, what it does is like it you can give it you can think it as like giving it a shape. Okay, you're just trying to remove few pieces here and there and trying to uh, keep it accurate. Training the model does not make it 100% accurate. Later on you try to do some kind of fine tuning. So that is how it works.
Yeah. Okay. I answered one of Satya's question. We can continue. Yeah.
Okay, so we'll jump into some more key concepts, which is called, first thing is token. Okay, these are parameter and your GPU and CPU. So again, as a beginner, these are the things which you need to understand. Okay. Okay, so first thing is tokens. So like I already spoke of models, and you are already aware of how models are published by all these companies and you are already using it. So what are actually tokens? Okay, so tokens are your fundamental unit of text, or of text within a model. So So whenever you write any kind of questions to your chatbot, like if you can see the screen, okay, here I have an example here. So this is one website where your text gets converted into tokens. Okay, so I have a very simple line here. It says, "Hello, can you tell me what AI is?" With a question mark. Okay, so this is one single line of text. When we are talking with the models, what we think is, okay, we are sending this sentence and the model is able to reply back. But internally what happens is this whole text or this whole sentence is broken down into tokens. So if you can see here, like it has probably 10 words here, including the question mark and comma. Here it has like around 10 words, but the total count of tokens is 17. The way it splits there, like every model has its own way of splitting up the sentences, and it also adds few more things in the beginning. Like here it is saying start, and like then it is saying, like in between it adds few more these kind of tokens for it to understand. Because LLMs at the core, the first thing to understand also is LLMs at its core does not understand English. Okay, so we always talk in English and we try to ask questions, but internally it does not understand. So it, and what it understands is these embeddings, okay, these numbers. So if you, sorry, so if you see these numbers, this is what the LLM actually understands. And to understand what are embeddings, that is again a very deep topic. I will not be covering that here in this session, but just to make you understand that tokens are what makes your LLM talk back to you, or you can send questions. Okay, and it literally breaks down all these sentences and then it converts into these small tokens. You can think tokens as vocabulary for LLM use. Okay, it's a language only that LLM can understand, not humans. Okay, and that's the basic thing of tokens. The another reason to understand why tokens are important, okay, is that it comes down to billing. Okay, so these services, okay, AI services, everyone is using that, are not free. It may be free for some time, but then if you want to use like advanced level, or you are a very heavy user, you have to pay a price, right? And you need to understand how this token system works. So if you go to any of these model providers, they will have always have a list, okay, of how much tokens each cost. So I just had one page here. Maybe okay, everyone can see this. So this is one website where you can see all these models and how much they are charging for each of these tokens. So these are like 1,000 tokens, and the output tokens as well. And this is the charge they are adding to these. So you have all your OpenAI models here, you have Anthropic models, Meta, you have all these Llama models. So it's not free always. So you need to always think in terms of tokens. How much tokens are going in as an input, and how much tokens are coming as an output. Input and output tokens. Based on that, you have your price here, and that's how these companies actually make profit, right? They don't operate for free, and they also have a lot of cost when they provide these services, and they charge us based on tokens. So you can go to this website. I'll put the link later, so you can see how things work. Okay. And the other website which I worked is this tick tokenizer, where you can put any kind of your sentences and it will try to convert it into tokens. And here you can also find whatever models you have. Like right now, this is Google's model. I can go and use um OpenAI model here. So there are a lot of I can use DeepSeek. Okay, so you can play around and try to understand how this all this works. Okay. Okay. Any questions for tokens?
How about non-text files?
Okay, so non-text files you can think of like images or something, right? Yeah, so those are also broken down, not exactly into tokens, but they are broken down into embeddings. Like you can see here, right? These numbers, they are directly broken down into these kind of numbers. And again, yeah, so image files are very expensive, are heavy files, right? So you'll encounter a lot of cost if you are trying to use those kind of files.
Okay. What is an output token?
Output token is the same. Output token is the same kind of token which are coming back from your LLM. Okay, input is whatever question you are answering. Output is whatever is coming back.
Okay. Okay. Yeah. Okay. We can proceed further.
Okay, right. So we come to another point, which is parameters. So parameters are again kind of a building block for any kind of model out there. Like I said, someone was asking about fine tuning, right? So parameters are what are adjusted. You can think of them as knobs or dials. Okay, you can tune them. You can tune the model to however you want the model to behave. So that is the best way to understand parameters. Um, as users, we don't usually don't directly deal with parameters, but it's good to know that like there are what it's good to know what are parameters out there and how it affects the model. So usually all this parameter tuning or fine tuning is done by the companies themselves, but some models allow the users also to do some kind of like fine tuning, and sometimes they provide those um mechanisms, but right now I don't see that happening. I think in the beginning they were giving the users to do some changes. Like I said, too few parameters, the model cannot capture complex patterns. Okay, this and too many patterns parameters the model might memorize. So it's always good to maintain a right balance. So the fine tuning, how it works is like they keep changing these parameters, and they try to maintain a very strong performance. Like they want the model, they always have a base case, like how they want the model to perform, and based on that they try to change the parameters. So the important thing here for us users is how many parameters are there in a model. Okay, so chat, this GPT model 2, okay, it had 1.5 billion parameters when. So this is the model kind of. You can say the way to recognize a model. So GPT-2 had 1.5 billion parameters. GPT-3 had 175 billion parameters. Okay, and GPT-4 has trillions of parameters. So you can see that as we go forward in all these models, every new version has more and more parameters. Okay, so what it does is that the more number of parameter it has, it's much better in a way to do any kind of tasks. Okay, and based on these numbers, right, 1.5 billion or 175 billion, you can try to estimate what is the size. Okay, so the best way for you to understand is to go to the Hugging Face website. So if anyone has visited Hugging Face, it's a website where all the models are you know uh, like here it's kind of a repository for all the models. So if you have never visited Hugging Face, you can go to huggingface.co, and you can find all the models here. If you go here or here, yep. You can see like literally everyone, every company. You have Microsoft, you have ServiceNow. Like companies keep publishing their models, and this is the best way. So if I take any model from here, let's take DeepSeek here. DeepSeek, like everyone knows, it's from China, and this was the model published. So you'll get all the information from here, from Hugging Face, what this model does, and like I said, what is the model size? You can see here, it's 685 billion parameters, right? 685 B, which is for billion, and So that's how the model is, like how big it is and all. You can understand there are a lot of other information available as part of model. And if you want to download this, please don't download this model, okay? This will not fit into your system, okay? These are really big models. Okay, if you see here, I don't know, yeah, the the one way to understand how much big size is, if you come into this file and versions, you can see here model 1, it's 5 GB, and then it just goes on like all these numbers here, 5444, the total amount, like you have a lot. So this can be almost like 100 or 300 400 GB file. So do not download it on your system because it's not going to run anyway. So these are big models used by big companies, and you need sophisticated hardware for that. But for you to understand how models are and what they can do, you can come to Hugging Face and understand more about any kind of model here. Okay, so that is what I was trying to say here in parameters. Okay, any questions on this?
So far, we are good.
Okay.
So,
Okay, and then the last part of all this is inference. Inference is what we call as testing, or whenever you are trying to ask questions. Okay, is what in terms of AI we call it as inference, putting the trained models to work. So you are asking questions, you are asking it to generate new images, you are asking it to do some kind of task. All that comes under inference. That is what we use the word as inference. Okay, instead of saying I want this answer, I want that answer, we call it as model inference. So why do we need that? Because we need to understand what kind of knowledge and like the model has, so we can try to get that knowledge. If it's a kind of a medical model or it has been trained on medical data, you want to get the answers, medical answers from that, and you also want it to make predictions, and you want to deploy it for your own personal use. So all that happens in inference. Okay, it's a real time operation. You ask it a question and it provides you answer in real time. So inference is basically you are just trying to check how the model behaves, or is it behaving correctly or not. Like I said, we as users, we do the inference, but the model companies, right, the model companies which provide the model, they also do inference on their side. And when they find out that okay, this model is not behaving as they expect, they will try to fine tune it. So again, like I said, they will change for some parameters here and there, and they try to fine tune it and again deploy back the model for users. Okay. So the whole thing, the way I like to look at these three topics, token, parameter, and inference, is the best example for me, which I thought is like studying for an exam. Okay, so model training is like, let's say from Monday to Friday you're studying for some exam. Okay, full Monday to Friday you study, and Saturday and Sunday you take a test. Okay, yourself you take a test, and if you miss out on some things, you again go back and read on those topics. Okay, and then you revise your content and everything, and let's say the next week you have your main exam. Okay, and that is where the part of inference come. That is where the main exam is, right? That is inference. So the Monday to Friday thing is your training, and then your Saturday Sunday is like your evaluation, like internal evaluation, how you are doing yourself, you evaluate yourself. And then inference is the main exam. Okay, this is how you can correlate these things. Okay, does that make simple for everyone? Okay, so I'll jump into the next important topic. So are there any questions?
yeah, one question you got is how does parameters matter at a hardware level?
Parameters matter at hardware level in the sense of size. The more number of parameters, the size of the whole model will increase.
Yeah, yeah, yeah. We can continue.
Okay, so we saw all these aspects from all these things from the software side, or the AI side of things. Now we come to the most important thing, which is the hardware. Okay, Now, most people don't realize that that AI also runs on your hardware. Okay, and that is the most important thing. Um, so everyone knows about CPU. I'll not explain what is a CPU. It's a central processing unit. Every computer has a CPU. What we need to understand as beginners is that the whole AI ecosystem, it runs on GPU. Okay, not CPU. Everything runs on GPU. So you need to understand what exactly is a GPU. So you can think of GPU as so the full form of GPU is graphical processing unit. And someone was asking why is it graphics, and that's a long story. So it's a graphics processing unit. And then what it actually allows you to do is like it allows you to do calculations simultaneously. In CPU, what happens is CPUs are very fast and they do it in a linear way or in a single way. Okay, and that's why you have multiple cores of CPU. Like one CPU is always slow because it is doing one task at a time. So that's why you have your modern laptops and everything have like a lot of other CPU, like 4 or 5 or 8 CPUs, and they work together, and that's why all the laptops are fast. But in GPU, what happens? Everything is faster than CPU. Okay, everything is in parallel, and all the operations and everything happens in a optimized way. And there are a lot of, again, GPU hardware is a very complex topic to get into. But if you are interested, you can always go and Google about GPUs and try to learn. It's a very fascinating topic. How these things make any kind of operations in parallel, and they perform it in a very fast way. Okay, so this is one diagram just to show you how things are in a GPU. Okay, so if you take CPU on this left hand side and this is the GPU here, you can see all these green components here. They are the ALUs, which are the arithmetic logic units. This is where the calculation actually happens. In a CPU, it's just one of these component, but in GPU you have multiple components which are like in parallel, and this is a reason why GPUs are much faster. Okay, and all you need to know as part of AI is that you can only run AI using GPUs. Okay, and it kind of you need to have CPU as well. The system, when you have a CPU, when the whole AI hardware, CPUs will always be there, but then you also have you need to have additional GPUs for running that particular task, right? Okay. So
Yeah.
any questions till now? And the way also it works internally is that some of the tasks go from CPU to GPU, and some of the tasks sometimes are sent back into CPU. It's based on, like, it's a hardware configuration. There are again a lot of, it's a very different topic where they're trying to send data from CPU to GPU, and there's a connection in between. This is a separate topic. It comes totally into hardware level. So I'll not go too deep into that. But yeah, you need to understand that GPU is required for running any kind of AI related jobs. Okay. Any questions here?
Let's pause. Any questions, comments, anything till now? How is the pace going on? Are you people able to understand? Is it making some sense? Any area to be okay? Thanks, Gaurav, for confirmation. Anyone else? So far, are we good? Is the pace okay? Venkata Satya. Okay. Okay. Sure. Okay. We can move. Thank you. Thank you.
Yeah.
Actually, I just have a one question. Yeah. Hello.
Go ahead. Go ahead, Megha.
Okay, so when we are running, suppose the training the model on the GPU, so like you are, as you mentioned that some portions are running on the CPU as well, right? So I would like to know that so how we can be know that suppose these lines of code where it is running, whether it's really on the GPU or the CPU, and how we can measure that the performance of that codes which are running on the both like how we can categorize that whether it is running on CPU or GPU.
Okay, okay, yeah, that's a good question. So again, you have a lot of other frameworks and all for that. You can't just run. Did you say code, like your programming code or something you're saying, or it was
Yeah,
course? Code.
earlier
Okay,
the
code.
code only
Yeah.
code.
Okay, so like yeah, when you run your normal like your JavaScript or Java code or any Python code, it runs on your CPU. But to run on GPU, you need special frameworks are there. You have something as CUDA. Those are special frameworks that allow the code to run on GPU. Again, it's a separate programming language. It's a different way to write programs. You cannot write programs like how you normally write, and then you cannot run that on GPU. So it's a different way to write programs, and then that is what runs on GPU, not the normal ones.
Yeah. As a programmer, Mega, you will be invoking some section of code to be done by the GPU. If GPU is available, it will run on GPU. If not, it will take the CPU path.
Okay, thank you.
Yeah. Yeah. Let's continue.
Okay, now we come to GPU cost, and this is one of the most important thing which people always forget. GPU is, again, like I said, GPU and CPUs are not same, even when it comes to cost. Okay, so I just put this slide just to make everyone aware what is the actual cost of GPU and how these things work. GPUs are really expensive, even in when you compare in terms of dollars and all. So only big companies which have good investment in with them, they are able to manage. They are able to buy all these kind of hardware. Okay, and I'm not trying to demotivate anyone, but this is the reality of today because of the all the AI hype and everything that is happening. The prices of GPUs have increased a lot. So here is one thing everyone needs to know, that is Nvidia. I don't know how many people actually know about Nvidia. It's a company which makes GPUs, and it's the biggest company in the world right now, which is making GPUs for everyone. So if you can see here, Nvidia has a particular GPU called H100, which which costs around $30,000. Okay, so this is how the price of a GPU is maintained. And the reason why I put this slide is like I want everyone to understand the the cost of having running a company or anything, right? It's very expensive, and what we see outside is that we only use the chatbot, or we use chat gpt or any kind of other products. We just ask questions and then we get the output, and that's it. We don't see what is happening behind the scenes. We don't see what actual hardware it is running on. That's why I was like trying to come to that, understand what is CPU, GPU, and then come to the cost. Okay, so this one piece costs around $30,000, and the companies actually combine this as a cluster. If you can see, this is like a cluster of all these Nvidia GPUs, and then you can't just run them. You have to run this into a rack because you need all the power supply, you need cooling equipments, and all that. So the whole thing comes around up to $250,000, or maybe it can also increase to $400,000 for running all these multiple GPUs. So just for the Indian audience, the Indian rupees, it comes to around 2 crores, 21 lakhs. This is what you have to pay if you want to have this kind of system. So that is one reason why you don't see much the Indian community or the Indian tech community getting into AI hardware or any kind of AI model companies and all not coming up, because it's very expensive. Because you have to pay just for this whole set, just one setup. Again, but this one rack of server is not enough for your AI needs. You need at least 10 to 15 of those. So that's 2 crores multiplied by 15. I don't know how much that will be. So that is one thing. And then the most important thing to understand is the electricity, right? This will not just run by itself. You need electricity, and just to run one CPU, one GPU again here. So like I said, uh, this one GPU, it consumes like 3,740 kilowatts per hour. Um, Okay, you can make the conversation, but ultimately you end up paying something around $100,000 again, $100,000 in a year or something, or in a month, to just provide electricity and keep this whole machine running. It's very expensive, and this is what people don't actually see. Okay. Any questions here?
Yeah, if you people are interested, there was a recent announcement. Intel and NVIDIA are having a partnership where x86 architecture, which we all know mostly. If you have done any of the computer science courses, you will understand x86 architecture very common. So to x86 architecture, they are bringing the GPU technology, whatever NVIDIA has proven to do. That's quite a great innovation that will help powering the PCs. Also Intel to make some data center chips. That's an interesting one. You can read those articles.
Yeah, correct, correct. Yeah, always go ahead and read about these things. There are a lot of news articles on what is happening in AI industry right now. So you have really good blogs or websites where you can read a lot of things and understand. That is the basic of getting into the AI part, like reading what is happening out there. Okay. So we'll jump into real world applications of AI models. So we already saw this, how the whole AI models can be applied. Okay. So you have image recognitions, recommendation systems, natural language processing, predictive analytics. So all these, again, I'll not go too deep into it. I already gave the examples where it can be used. Predictive analytics is like you can use it in supply chain, if you have ever worked in logistics and all. Y- So these are the things which are already there, but using AI you can enhance those operations. Like there are a lot of new solutions which are being put out in terms of supply chain. How do you want to optimize your supply chain if you are in logistic, or you want to do preventive maintenance? Okay, preventive maintenance is that you try to understand, like if you are doing something with trains, okay, and you want to before a part of a train or some component of a train degrades, you want to fix it beforehand. That's where your preventive maintenance comes in. You can use any kind of image recognition devices there. You can take pictures and try to analyze if this component is going to fail in future. So those kind of things can be done with predictive analytics. Natural language processing, we already saw how we are able to generate texts and all. Image recognition, this is again same thing. You can provide any kind of pictures, and it is also able to create new pictures. All that recommendation systems I have explained enough. Yeah, so now we look at popular AI models in 2025. Okay. So these are the models out there in the market today, and people are like using them for all their daily tasks. So recently we had GPT-5 by OpenAI. So always try to understand what a model is and which company has produced that model. So you'll have a very good knowledge when you're trying to talk with someone, or when you're networking with someone. Always try to understand what the model is and which company has produced it. So you have ChatGPT from OpenAI. Then you also have Gemini Ultra from Google DeepMind. So this is a Google product, Google model. And there's another company called Anthropic, which has produced Cloud 4. So all these models are different in their own way, because OpenAI, like I said, I gave an example of training, right? Training the model. So OpenAI has its own technique of training their models, and Google again has its own technique. Anthropic has its own technique. So they are not open source. They are proprietary, because they are different companies, and they want to make profits. And so they have their own models. You have Meta. Meta has a model called Llama. Llama has been famous because it's open source. What open source in terms of this is that you can directly download this. Again, don't download it on your system. If you have a big enough cluster of GPUs and all available, you can download and run these models. Then you have DeepSeek. DeepSeek was like a model from China. Then you have Grok, which is from X, which is the Twitter. Formerly, it was known as Twitter. Then you have GitHub Copilot from Microsoft. So these are like kind of the leading models right now. You need to just understand these if you're talking with someone, and so they'll come to know. Okay, you have a good knowledge on what is happening in the world of AI. Okay. So any questions? So any questions till now?
Yeah. Okay. No questions so far. Yeah.
Okay. Okay. I think we are almost towards the end. Okay, so we'll look. So we looked at the basics of the AI, ML, and deep learning. Okay, how they are and how they are trained or how the training happens, and then we also went into the part of hardware and how all these things are deployed or where they run. So we'll come to the most important thing, like for developers. I think most people here are like they are into programming and all. So for developers, what does AI do? Okay, so how you want to build AI systems for yourself or what you can do? Okay, with that, you already have AI frameworks here. So again, Google and Meta, they have created their own frameworks of how they run these systems. So you have one popular framework is called TensorFlow, which is from Google. Again, it's a machine learning framework, and again, it's a very vast framework. If you get into that, you can explore how to do things and all. PyTorch is another framework, which is like Python. It's literally, if you know Python, it's very easy to understand PyTorch, and it allows you to do any kind of programming. Like someone was asking a question, if you run PyTorch, okay, if you're doing any kind of if you're writing code in PyTorch, it will directly run on your GPUs. Okay. Keras is another kind of a framework here for machine learning. Hugging Face, like I showed you, the Hugging Face website. The Hugging Face has released their own framework called Transformers. Okay, and these transformers are like they allow you to do any kind of natural language processing, text classification, summarization. So these examples of transformers, I had given it in the previous session which we had done with the Byte of Python. So there I had done the demo for Hugging Face transformers, and we were able to do classification, summarization, and all the demo was done. So you can go back and refer to those videos, and you can see how this we can use all these things. Okay. We'll now jump into the jobs in AI and the roles. Okay, so this is one of the most important thing. Everyone is like kind of concerned, like if you have a knowledge of AI, like where you can see yourself and what kind of jobs can you get into. The most important job here is machine learning engineer. If you have done any kind of machine learning courses and all that, you can get into machine learning engineer. And again, it's part of data science. Okay, and there's also software engineering involved, so I'll not go deep into each of these topics here. AI research scientist, again, this is like a PhD level thing. You can create new algorithms there, and new things which are constantly happening. So right now in AI, there are hundreds of research papers being released every day. Okay, so that's one thing. AI research. So, like I said, AI ethics specialist. Like I said, like you have to be careful about how AI needs to be used. So you can always we can always have people who are specialist in that and who are responsible for putting in safeguards for for bad usage of AI and all those things, and any kind of social impact it may have. There have been incidents which people are not aware. Again, uh, people actually have lost life because of some wrong usage of AI and all. So those kind of things all need to be taken care, and that is where these kind of ethics specialists come in place. You have data scientist, which is normal. Everyone knows about data scientist. AI product designer is any kind of new product you want to design with AI. You want to use AI within the product. And then solution architect, obviously, every enterprise is having a solution architect, and the way you can use AI into those solutions is part of this. So these are like the normal the job roles going forward, which can become popular, and you can start looking into these kind of roles and try to understand, right? And any questions till now? Okay, if not, I will jump into this section. So this is like a very, very high, low level overview of what has happened in the world since 1900s. Okay, so please just pay attention the whole thing. This is what I have covered, and this is what is happening. So just need to understand. So everything started back in 1900s. This is when the whole computer revolution started. Like people started trying to invent the vacuum tube. If you know about computer science, history of computer science, you know the vacuum tubes and those got invented. So when the actual AI comes is in 1950. So this is Alan Turing. If you heard of Alan Turing, he's like you can consider him as the father of modern computer science, and he was the first person to argue on if a machine can be intelligent or not. Okay, and this is where the first steps of AI started in 1950, and then again people started contributing to the research, and the first term of AI was actually born in like 1956, and then slowly it proceeded, and people were again working on few research items. So the first you have in 1957, you have your first perceptron. Perceptron is the again like I explained about neural network, which is a replica of your human brain. So perceptron is this one single cell which allows you to think and all. Okay, that's what. So they were able to produce the first artificial perceptron and the first AI program. So things went along, and slowly you had a lot of things happening. And then you in 1986 you had propagation. Back propagation is the kind of a heart of all the machine learning algorithms. Without propagation, your machine learning or any kind of deep learning algorithms will never work. So that's how this started in 1986, and slowly again things started. And in 2012, you had something called as AlexNet. This is where the actual deep learning actually started. This is where the image recognition part started. So the AI or your deep learning was able to recognize images and give output, like simple images. Like let's say you give a image of a cat and it's able to recognize it's a cat or not. It's not. So those kind of things started in 2012. Slowly, then in 2017 we had Transformers. It's a paper written by Google. So this is one of the most biggest transformations in AI history. After Transformers paper was published, uh, again companies started doing their own research, and then they finally came. We are here. A lot of things happen. Like there's a big boom here. You can see like a lot of things happen. And today, in 2022, you have Chat GPT, and again there are like in 2024 you had some countries, they have their own AI act, which is like rules ethics on how AI should be used. And then today we are in 2025. Again, there like a lot of things are happening. We don't know where it is going. There's no stop to this. Like every day there's new innovation happening, and all these things are happening. So this is a very high level overall picture from 1900s or 1950, you can say 1950 to 2025. So the whole picture landscape of AI. Okay. Okay, so what is next? What is next is like what is going to happen, what you can do as a user, as a developer or a programmer, what you can do. You can gain proficiency in programming languages like Python and Java. So if you know AI, most of the AI products are literally written in Python. Java also is there out there to support AI. I think right now there are some libraries from Java that are supporting. Again, like I said, frameworks try to understand machine learning libraries like TensorFlow, PyTorch, Keras, and all these. Try to understand how what you can do and try to implement small programs in them. Work on real world projects. Try to build chatbots, image classifiers, recommendation engines. Again, if you want to build any kind of these projects, you need to have knowledge on programming language like Python. You can build any kind of any of these projects out there. You can also learn about data analysis like pandas and numpy. So all these, I think pandas, numpy, and Python was covered in the Python session which we had, the bootcamp session for Python we covered. So this will take care of all your programming related to AI. So if you learn kind of this, explore cloud platform. So all the three major cloud platforms, AWS, Azure, and Google GCP, they provide new AI related what do you say services. So you can use those services and you can build any kind of solutions based on that. um, ML ops is a different domain, a bit different domain. So if you are familiar with DevOps or any kind of infrastructure or SRE kind of role, if you're coming from that background, ML ops is the same kind, but here what you do is instead of deploying your software, you deploy the models or you deploy these kind of AI products. So they term it as ML ops, which is machine learning operations instead of DevOps. So you can also get into these kind of ML ops domain, which is also very lucrative. This is like the basic part. So whatever I have covered till now is again very basic. I wanted everyone to understand what is happening in the world of AI, how it is related to us, and what happens in the hardware level, and all those things. Again, you have something for specialization. If you want to get too deep into other things, you have other specialization here, like fine tuning, multimodal. Multimodal is when you are able to combine a model with vision and audio. So you're like right now all the chat GPT models are multimodal, right? You can send pictures or you can send voice messages and it is able to respond. So it is a multimodal model. And then again, ethics and all are very important, and there are a lot of cutting edge research which is going on. So keep reading news, keep reading articles, and try to understand what is happening in the world today. Yeah. So any questions till now? Because yeah, this is the last slide. So I'm towards the end of the session.
Yeah. Sumant, we have some good questions. Let's go one by one.
Yeah. Yes.
One question is, what is the difference between Perplexity AI, ChatGPT, and other AIs? Why it's a boom equal to ChatGPT and OpenAI?
Why is it different? The first part of the question.
Why it's boom? Chandra Kumar, can you please tell the second part? What does it mean? Like why it's boom equal to ChatGPT? ChatGPT, OpenAI are same. OpenAI is the company, ChatGPT is the model. Okay, let's first take the first one. What is the difference between Perplexity AI, ChatGPT, and other ones?
Okay, why is okay? So these are different companies again. First thing you want to understand is Perplexity is a different company, and Chat GPT is actually a product from OpenAI. Okay, OpenAI is the name of the company, and Chat GPT is a product. Um, and the difference is, yeah, obviously, they like I said. So these two companies they have their own models, and Perplexity, you can think of it as like it's a it's an aggregator. What it does it is like it itself subscribes to all the other companies, okay, and then it brings together all these models for you. Okay, so within Perplexity you have Chat GPT or OpenAI models. You also have Anthropic models and all that.
Yeah.
It's kind of an aggregator. You can think of
Yeah.
that.
Yeah, I can add a few more points. So each one of it, right, is started with a different philosophy also, philosophy and use cases. For example, if you start with Perplexity AI, Perplexity AI is a direct competitor to Google. We imagine this as a AI-based Google search because the difference in Perplexity, what is unique about Perplexity is the hallucination ratios will be very less, which means that the model trying to cook up something and then tell you that, say, for example, who got the Nobel Prize. Recently, if you remember, Mohanlal gave a speech talking about certain things, okay, about he being the youngest person to get the national award in Malayalam community, for example, right? So later, many articles came in that he was not the youngest, probably there was somebody else who were younger than him, like Lata Mangeshkar and also. Sometimes people, when they write speech or when they try to write research papers, if you use ChatGPT, there could be good amount of chance of hallucination and some facts getting cooked up. If you use Perplexity, what it will try to do is, as Sumant mentioned, it will aggregate the data from various sources and stitch together and give references. So it's very, very grounded to the reality and the internet, what is available. So you can do fact checking very quickly, whether in the same year something happened or not. It's very easy to do that. Later, when ChatGPT and all started catching up with the web search option and others, they started catching up. But the origin in which Perplexity started was it aggregates the web, forms nice articles and the output that you need, merging various content, but it will always keep it truthful. It's more like a research paper with references to all the facts rather than it generating the whole thing like poetry or imaginative fiction story. Okay, that's the difference. Second thing, ChatGPT and Claude AI. Claude Anthropic has been formed by the some of the members of OpenAI. What they felt hugely is somewhere OpenAI started with the philosophy of open source to have for the humanity, building models for the humanity. Over a period, for whatever reason, they became little more commercial and more proprietary than any other open source model that we have. So Anthropic philosophy, two things. One is really focus on the human beings and the betterment of human. Second thing is they have an approach called constitutional AI. So the way if it is reinforcement learning and the training that all happened, right? ChatGPT did with, aggregate all the data, and there were people who are human beings who are validating the output to see for integrity checks, for any ethical ones, or violations of bad words and bad connotation biases. They did a human reinforcement one, which means that human beings were validating a lot of things and doing that. Whereas Anthropic went with a different approach, saying that constitutional AI, which means they told the rules that you should never violate this, you should never go and harm any human being, you should not give any references which would harm the mental health of the person. They wrote those ground rules and told, now you go ahead and then give answers. So there is a clear guardrails that Anthropic and Open or Claude AI will do. So other aspect also is the depth of human connect. Each model has a personality by default. You can tell ChatGPT to be concise, research oriented, or very direct approach in answering. But in some cases, Claude AI, if you use, you will get a more human touch. If you have any moral dilemmas, or if you have anything which is ethical and human part of it, Claude gives a much better thing than even ChatGPT. ChatGPT may give like a statement of something, whereas Claude may give in a different model. So each model's origin and philosophy is different. If you take Grok, for example, Grok will give you, it's okay to be crude. Many times if you want to generate a picture which looks like a actor or actress, it's okay to generate that. Whereas in all other models, they'll say, no, I cannot generate a picture of this person because it will be a copyright violation or something. Grok is little more radical in terms of giving its answers. It will give more precise. It is free to search from X.ai, which is our which is our Twitter and others. It will give a lot of real-time processing, so you will be more grounded to what's happening in the current world. So if you want to search anything about Gaza or the things that are happening in that world, I want to get a condensed view. I'll get a more opinionated and very clear view, unbiased view in case of Grok. Whereas in ChatGPT, there may be so many guardrails that it will be trying to be politically correct. It will try to tune it all that will happen. So imagine each model as a personality. For different use cases, each one will fit much better. For a common questions, if you want to do math problem, science problem, if you want to learn something, all will look same. But if you go into deep specific cases, you will start seeing the variations in each of them. Does it answer, folks? Does it help?
Yeah, that was a very detailed answer.
Okay. Okay, yeah. Next, let's see what is the next question. Next question is cloud provider. Cloud provider is the most preferred. So which cloud provider is the most preferred and popular one as of now in terms of job opportunities to build, train, fine tune, evaluate, deploy, monitor models, all overall entire cycle. Any suggestions, preferences? Anyone? Sumant, you have idea? I do not know much, but
No, I think all the major cloud providers have these things built in for build, train, fine tune, and everything. They have built the services around them. So I think yeah, Google is kind of leading in terms of good model right now. So you can go get into GCP and try. Again, it's based on how what kind of services you want to build actually, because all of the cloud providers give you access to all these AI models and all, but how do you want to build a later on, like you want it to connect to some other components as well, right? So that also matters. It's not just these AI components. You have your Kubernetes and Docker and all those how you want to build those things also, that also matters, right? So based on that decision, you can choose any kind of provider. For now, I think GCP is good.
yeah.
Then AWS, yeah.
From job opportunities and learning, right? If you're just a student or a person who is learning AI, anyone will be fine. Okay, Google sometimes being more approachable and it looks more friendly in terms of because they have built a TensorFlow, they have built the models and all that they support, the tensors that they have, the TPUs, what we call, right? If you are a Google Colab, if you are using, you will feel it very comfortable to build things in the Google ecosystem. But if you see the commercial companies, lot of companies which use AWS, they will be finding it all the AI ecosystem that Amazon gives to be more friendly because they don't want to redeploy their whole cloud environment into a different environment just because of AI. So everyone is giving very competitive, whether in terms of pricing, whether in terms of the TPU, GPU, or whatever you call the high performance computing part, everyone is giving. So if somebody is in an Azure ecosystem, enterprises who are more logged into Microsoft, they may find Azure and the equivalent ecosystem more friendly for that. Opportunity seems to be there everywhere. If you are more looking for a job opportunities, it may be changing. Whether you are aiming for a startup company, whether you are aiming for a mid-sized company or a very large company, they may be varying by high degrees.
Yeah, great.
Next question we have. Yeah, programming languages. Why Python is popular for AML, not other programming languages? Thanks, Sanjay, for asking. Yeah.
I think because the library support from the beginning, my Python has data related libraries, and those were used in data science, and that's how it has progressed further. Other programming languages were more concentrating on normal programming aspects, right? Like object oriented and all that. They were concentrating more on that. But Python, it kind of opened up a lot of developers to concentrate on data related things. So yeah, you
Yeah.
want to add something?
Yeah, sure. So Python, what I see is, I think Suman put a very clear picture of AI generations, right? Right from beginning, then AI winter came in, then another AI winter, all these patterns, if you see, it's good to understand the evolution. Very beginning, the programming languages that were very friendly for AI programming were Prolog and Lisp. Okay, Prolog is a very ancient language, but it is still powerful as of today. If you want to solve some problems which are, you have set of rules and constraints and you want to do some program, you can do in very less number of lines of code. For example, let's take a use case, right? We all have our calendars, let's say 20 people having their own calendars, and I want to find a 30-minute slot which is friendly for everyone to access. So in Prolog, what you do is you write all the facts and then you will write a rule that find me a slot which is 30 minutes available in everyone's calendar for the next 12 days. Any 12 days, you pick up one slot, right? So those kind of rule-based writing, or you want to build a knowledge base, Prolog is extremely good. Then comes Lisp. Lisp was again yet another very popular. It's still used in certain domains. Lisp is very good because the program is also data. So that is a very beautiful concept. Only Lisp has not many languages have. In Lisp, you can treat a function as data. Data and program are interchangeable. That's the beauty of Lisp. So a lot of people used Lisp for that reason. AI also is built using Lisp in the early days, where there was a rule-based AI or expert systems being built. Python, I see the popularity of Python for two reasons mainly. Python is very friendly for beginners. You want to get started with programming. Programming Python could be your first language to get started into computer science and coding. That's a very friendly one. And the ecosystem of number of libraries that are built are huge, huge, so massive that no other language comes even closer. The second closest probably could be JavaScript because the TensorFlow JS and all what are built by Google, that may give an advantage, but still predominantly Python is ruling because of these two reasons. Okay. Next question. Just like how a Java application is consuming many Maven dependencies of various operations, we can use LLMs for when creating applications. Is the correlation correct?
No, that's not the correct way. Okay, Java. In Java, you have dependencies, right? Correct. That is correct. LLMs are not dependencies. LLMs are their own separate products. You can have programs or you can have web apps which connect to these LLMs. Okay, it's not a dependency like in Java, you define it and it is placed into that. It's not like that.
Okay. Okay. Thanks, Kamal. Yeah. Okay. I hope we answered all questions. If there is anything left out, please message us and then, or you can unmute yourself and ask your question. Could you please tell us how was the session? Because this is to bring people, create interest, give a bigger picture in terms of what is happening in AI. For us to continue this is a meetup group. It's not one session that we are doing. We will continue to do. Please let us know what did you learn new. You can put it in chat. What did you learn new today? That is your key takeaway. One sentence, one point. Can you please cover? In the meantime, if you have any questions, please post us. Okay. Part breaking for me at least. Sure, Venkatramana, thank you. Can you please tell us about the topics you planned? Oh, okay, sure. Sumant, you want to tell about briefly, we want to do a paid course, more hands-on means show and tell kind of thing where we'll build a model, show some inferences and all. What do you plan to cover in that?
Okay. That we can do on a smaller scale. We can try to do more like how I think we can do that. We can do a kind of a training of a model and then some kind of fine tuning and then inferencing that can be done.
Yeah, yeah. So today's theory, whatever we learned in terms of what is it, you will get a more see-through experience. How do you start a model? Where do you pick up the data? What are the data sets? What is a model? How does that conversion happen? Finally, how does a model look like? And then how does it do inferencing, giving various input and seeing the model is working? And probably tuning the model for efficiency, pick up a performance parameter and say, how do you improve it? What are epochs? So very basics of it we'll cover. With that, the same philosophy is applicable for across. Even if you take the large LLMs, probably some way of supervised and unsupervised learning will be there. So we will try to cover those topics with more coding and showing on what is happening below the surface. Okay, very happy with the content. Great session. If you can cover some hands-on and lab, yeah, that will be help a lot. Sure, Gaurav. Yes, I agree with Gaurav and others. Upcoming session. Upcoming sessions, we will plan it. We will be registered into the meetup, Darling Meetup. I also plan to do a newsletter. Whatever the world of AI is very fascinating, very interesting. I find it quite interesting that I spend a lot of time in that one. I'll continue to send the newsletter. So there will be a newsletter. There will also be events that we'll publish. maybe anywhere between 2 to 4 weeks, expect some session to be popping up. You will get a notification if you are registered into Darling Meetup. We'll post it there. Okay. Okay, so I have learned a lot about tokens model training under the hood. Okay, good. Thanks, Sumant and Janardhan. Okay. Are you going to host today's recording videos YouTube? Yes, yes. I'm going to, once I have the recording available, I'll post it on YouTube. I have to create a new channel called Darling Meetup. I'll create it and do that. Maybe by tomorrow, I'll send an email to all the members of the meetup group to explore that. Okay, thank you so much. Thanks, Suman, for putting all the content ready. Wonderful. Thank you for being a volunteer here. Thank you so much.
Yeah, thank you everyone for joining.
Yeah, bye bye. Thank you all. Stop recording.